All right, so here's a brief tutorial of Tracker where I have taken the 4-bar mechanism that I've used as an example, I believe in class 16. I built it. Here, let me show you. Well, you can see it in the video right here. But I've captured it with my GoPro, and now I will create a new Tracker analysis. So I come in here and I go open file, and I've named it example clockwise. All right. And it's going to take a while to load up because these are big files. I used a GoPro. I tried an iPhone first, but the resolution wasn't close enough. But still, I'm not actually all that happy with the resolution of my GoPro. I might re-record some of these videos. They are kind of large. I should have used better lighting. The resolution here, it looks a little, I'd like to be able to zoom this in and get better focus everywhere. But this is for a demonstration right now. Okay, so I've loaded it up. I want to limit how much I do because I think I have a couple rotations in here. Let me only do, well, I just tried it with one rotation. Maybe one rotation is a pretty good place to start. So I took these little black arrows and reduced it down. So I wanted to start it kind of like at the omega 2 of being 0, or just right around there. Okay, so I've limited my analysis to these two black little arrow guys right here. Now I want to go in and do a few things. I want to establish where 0 is, my coordinate axis. So I click on that coordinate axis and I can drag this around, and I'm going to use the trackballer to get real close in there. And now I want to line the x-axis, and it turns out I'm actually really close. But if I could go over here on the right, I can shift this and it'll pivot about where I decided that origin was. But one of the problems you'll see is there's skew, right? As hard as I try to get this thing to be perpendicular, there's going to be a little bit of that perspective error going on there. So because we could see that top surface, it's definitely coming down from the top and kind of angled just ever so slightly. Now we want to have a measuring stick, so we pull this guy right here down and go new, and I'll go calibration stick. That's actually the name. And I've posted on here a grid that I measured out, and I'm going to go on top of that. I'm going to use that, and these are in 100 millimeters and 10 millimeter increments. So I'm going to hold down Shift, and you can see that the cursor changes, and click there. And now I'm going to scroll back over here with the wheel and click in there. And once again, holding Shift, I click, and I can see that I have my yardstick. All right. And if we click on that yardstick, it shows you that it's measuring on the screen as 652, and it's showing meters. But let's make this 100. And if we go to coordinate system units, we could change these to millimeters, right? And it doesn't really matter, okay? Now, we're set up pretty well to do the rest of our analysis. We have to create point mass right here, and that'll be point mass A. While I'm here, I'm going to create point mass B as well. All right, so there's A and B. Now we could go in by hand and do this, but it has a nice feature. It's a little tricky. I'm hoping it'll work. This will be the frustrating part, but it has this auto tracker thing. You click right over there, and this auto tracker comes up. Notice it's on B. Let's go to A instead, right in there. And if you read the instructions, it says to hold down Shift and Control, and then hover over the part that you care about right there, and it picks it up. Okay, hopefully. It tries to pick it up. It kind of shows you what it's looking for. This is very tricky. You might have to do this a number of times. But once you put that in there, you go ahead and try it. Hit search. And it'll start stepping through here. And this is really the important thing. And some of the shadows can really mess with this. But this is something you could do by hand. You can go by frame. It's why you want a high resolution, is because it depends on the frame lengths, and how many frames that you have per second. And it's finding these. So these are all the steps. And by the way, this is not going to be a high precision one right here. And I've created some videos for the two parts of the homework that started off, I think is it homework 5 or homework 6? Anyway, I created 2 mechanisms for those, and we can see if those are going to be good enough videos, and from your feedback, I can make better videos and upload those. Try to improve on this, but we are there. We made it. Okay, so it didn't stall. Sometimes it'll stall out and it'll give you some messages that it got messed up and whether you want to skip it, but then it'll give you warnings not to skip it. But we got really lucky that it did its thing right here. Okay, let's take a look at what the results are right here. Okay, so up here in the upper right corner is a place to plot stuff. It was selected for Mass B. Now you'll see Mass A. And also down here below, you could also see as in table form, here are all the data points for time. So you know the time increments, the X and the Y position. Up here in the plot position up above, that's just plotting these just like you would in Excel. And we could put 3 plots up there. Let's put up 2 plots. That's fine. And there's a couple other things right here that you can turn these things on and off, but don't worry about that. So right here over onto the side, it says the X position, and right here is the Y position. So you can see them, but you could change these to anything. One thing I like to do is let's change this one to the Y position and change this one to the X position. And that should be the shape. That could be the coupler curve that we're looking for right here. And it actually tracks pretty well. But as we'll find out, position does a lot better than velocity, which does a lot better than acceleration. But here is the velocity versus time in the X direction. And here's the velocity versus time in the Y direction. You can also have the acceleration now in the X direction. You can see it's much scratchier. There's a whole lot of jerkiness going on. That could be from the measuring, but it also could be the mechanism isn't necessarily perfect. So we do want to check that thing out. That's why I have Mass B in there. Okay. So another thing, we need to figure out what the input omega is going to be. So let's do another one of these and have our fingers crossed. We'll see if it works. So on Mass B, what we're going to do, go Control Shift. Let's click on. There you go. Okay. So we're clicking on that little nut right there, and it may or may not work. Let's try it. Let's see what happens. All right, I hit search and it's not doing it. Why is that? This key defines the frame. Maybe we need to start at the beginning. Okay, let me back this thing up. I thought it would automatically start to search. But let me go back and I will delete maybe the later point. All right. Okay. So let me start it again. Control Shift. No, not there. Down here. And I might want to get the reflection maybe. I don't know. Let's see. It's searching around. And let's see if we do the search. All right, it seems to be okay for right now. It might get messed up by the shadow. You see the little box around it? All right, we're doing okay so far. We're going to do this to get the RPM. We could actually probably just measure it ourselves if we'd like. And when in doubt, that might be something worthwhile. We could also just, we did start it at what we think is 0, and it ended at where we think it is 0 degrees. So we could just look at the beginning and end time and establish what the revolutions, and calculate the revolutions per minute or radians per second that way. But it's doing okay so far. I think we got lucky. Okay, we're almost there. Kaboom! All right. So now we can analyze that. We could take and come up to our plot window and go mass B right there. That doesn't look too bad. Let's take a look in the y direction. That's good. Now let's go x versus y. So instead of time, we'll make that x. That looks like a pretty good 0. Pretty good circle. I don't know why I call it 0. And then for here, we could also go what the velocity is. But so you can see how sketchy that is, right? In the x direction, see how sketchy that is. So that's going to be some of the reason why we get velocity. That's going to be all scattered all over the place. Like this right here really should be a constant value, but you could kind of see the variation just from the nature of this. We can get the acceleration. We can see that. We can see the acceleration in the y direction. Those should be, just because it was sine waves. So we should be looking at the inverse sine waves, right? Here's the x. Here's the x position. Here's the x velocity, and then here's the x acceleration, and you can see that it's got quite this scatter going on right here. But we can also go for the angle right there. That should be a sloped line, I believe. No, that's the acceleration angle. Let me try angular position. Okay, so see, it's going to reset as soon as I think it only goes from 0 to 180 or something along those lines. But you can get the angular velocity. Right, so let's see if the angular velocity, and that should be something that's kind of constant. You could see it's telling you that it's like varying. So we have the average and the instantaneous. So there's going to be all kinds of issues when it comes to trying to do this analysis, but that's the nature of these sorts of things. So what we could do down here, by the way, we can also make a table in the table part of it down below where we can add things to the table. Like we could, now it just says X and Y and by default has time, but we could also have VX and VY, but this is for mass A. We could add this and add the accelerations if we want. And I don't know if there's a way to export this, export. I can't say the word export, but what you can also do is just come down, hold down Shift, grab it all, Control C, and let's see where my examples were. I think I have it under solved. No, not resources, non-book. It's under solved problems, and I believe it should be. Is it? I think it's homework 7 examples. I think that's where my most recent velocity and acceleration analysis for this example took place. And it says 4-bar velocity homework. That's not it. It would be 4-bar acceleration example. Not that one. Okay, here's it with tracker. There you go. Yeah, and so I already put this in here. So you could kind of see what some of these results were for a different run. But let's see. It does. I think all of these were going to be fine. So let me, I think I will click right there. And it's messing that up. So I think I'm going to come back up here and go right there. All right, so I've already pre-graphed some of these things out, interestingly enough. We could start to try to see them. And I might have this going the wrong direction. I think that might be my problem here. I think I did a counterclockwise. Yeah, I did a counterclockwise, and I should have done an example where I did this in counterclockwise. But you do see the motion right there, right? We can see the motion, and we can see I plotted out the motion right over here. I don't know why there's more than one. Let's see, what is this guy right here? It's plotting both of those. I don't know what these guys are right here. Nope, didn't want to do that. So it seems to be plotting it twice, but it's only one revolution. I don't understand that. Oh, you know why? Because I think it has some information down here. Yeah, let me get rid of some of this. By the way, you could tell from their tracker analysis, right? So this is an interesting thing. Check out how they got their velocity and acceleration. It's the identical way that we did, right? So let's try it over here. I'm going to try, here's our X and our Y position, here's our velocity, and here's our acceleration. Let's see what happens for velocity if we go equals, parenthesis, we need to go, that's fine, equals, parenthesis, the X position, that's just the one after, here's the one just before, divided by the time just after minus the time just before. Boom. And look at that number right there. I think you can guess. Look at the number right below it. I mean, just picking any number right over here. 1.515, 1.51, I didn't say 5. All right, so you can see that's exactly what they've done. Like we can make this, we can increase the number of sig figs right here. Oh, it won't let us. Let's do it this way. Right here. Let's increase this one if we can make the thing bigger. Check that out. That and that are identical. So they're using the exact same method for their velocity and for their acceleration that we have in our Excel when we're doing the numerical analysis of the thing. You can kind of see, okay, so this up above is velocity. And we have to be careful, we haven't stuck in the correct angular velocity. We could come back in here and let's see for B, right? So B, it charts, okay, that goes from 0 all the way to 4.972 seconds for one revolution. I mean, we think. Like just about, right? If we could take a look at where X is, yeah, that looks like it's going to be the maximum. Yeah, the maximum X is just about there. And we take back over here, that's just about where X started. So we actually did a pretty good job of where we started. So 4.972 seconds. So we take 2 and pi. And let's divide, and we have 1.264 radians per second. Now, granted, it's going to be in the wrong direction for ours, but oh, look at that! I already tried it before. 1.264 is our radians per second. So that's going to be the thing where we try to match up. And so, like, let's see, right there is our velocity, and you can see that we have it backwards, right? So I don't want to do this live where I try to figure out how I can go backwards. My recollection was that I had to we go negative this way, but then we had negative time. So in order, but then we also have to change the angle, right? We have to change like our maximum angle, like, yeah, well, okay, that's what we'll do. We'll make our time steps back. So let's start with 1440, and yeah, I think that'll be right. 14, well, 14, yeah, maybe, okay. Let's make this positive, and let's make this -5, and let's make this one 1440. Boom. But no, that didn't work. I forgot how I did it now. So we want to have to divide through. Anyway, we can look back and I'll try to figure that out later on here. I don't want to like get rid of a video that was like useful to us. Let's see, it's got to start out at 0 and it's got to keep going, but we want to make our reverse our angle direction. I forgot how to do it. Anyway, I have to think through again. But anyway, that's our tracker demo. And we want to get these so that they match up. What I did, I recorded these going both clockwise and counterclockwise. So if it doesn't match up and you need to match it up, you could just analyze the one that's going in the opposite direction. One last thing, I could, if I could get my scale correct, I could do a new tab. And I have an option of zooming in, right? So I have one where I close up, and let's see if it will work for here. And how long is my video? Is this too long? It's already 20 minutes long, 21 minutes long. It's not too terribly bad. This is something that you could also I would recommend that you go to the tutorial on the Tracker website. He does a pretty good job so you can understand the different things. If you need to troubleshoot, you want to have a deeper understanding, you don't need to just spoon feed from what I provide you. All right, so here, I don't know, I think, well, what I'll do, here, I know what I'll do. I will move this to, let's see, I'm trying to think of a good spot where it might be a good reference to this thing. Like maybe like right, I'm going to try to make that thing vertical. If I can. Won't let me. There you go. Just trying to find a good spot. Maybe we can measure from. It doesn't really matter, I guess. It's kind of. It would be kind of nice, but anyway, I'm just eyeballing it right here. All right, and then we do our yardstick or a calibration stick. I keep calling it the wrong thing. Hold on, Shift. Boom. What I'm impressed with is that this is a free software, right? And let's see, we'll click on that, and sure enough, it isn't what we expected it to be, but let's kind of, is it going to let me go backwards, back? Is it going to let me type anything in there? I guess I have to type it down here. Okay. 100, and then we want to change the units to millimeters, right? And we create a mass. All right, so we're only going to use mass A this time, and then we're going to do this auto tracker and Control Shift and that guy right there. All right, so we can be hopeful. Let's be hopeful, and let's go searching. And hopefully, with being closer up, we're going to get a higher resolution. And we might be able to, well, we could actually judge it when it returns to the same position. We could use that as the means of where we're timing this, right? We could time for a particular, the time it takes to get a particular position, you know that's going to be the same as the RPM, right? Because we have a repeatable thing. It's an interesting process. I'm really kind of fascinated by this. I would love to have some more opportunity to play with this, and then I'd be interested in getting a much more sophisticated tool. Dr. Asaki and Dr. Rico, they use one for biomed stuff where they're filming, like for instance, people walking, so they can understand some of the mechanics of walking and that kind of thing for trying to develop prosthetics. And And that's an important application of mechanisms of this whole topic. It's a subset, right? That's it's a very it's a, you know, it's a I don't know, particular, I don't know, words. I'm tired of talking, really I am. You would never think that. You wouldn't think from my grade card as a kid, you know, that they would ever say that little Teddy Deal would be tired of talking, as I never got tired of talking. But I am. I'm really tired. I'm really, really, really tired of talking. I've been talking to a computer a lot lately. So this will be interesting to compare the smoothness of the velocity and acceleration. And I forgot to adjust the end point here. So I'm just going to let it go. Even that, you know, this video could be too long. We already should have been able to get most of what you needed to out of this video in terms of the processing of how to run this tracker program. It's pretty simple. Hopefully you have a computer that you can run this on. That was one concern that I had. And I think people will get a wide variety of results. I don't think it's going to be like the most repeatable thing in the world, but we'll see what happens. But I want to see some analysis of real-world things. This would have been this would have been a lot more enriching if you could have designed your own mechanism, right? Where it was something unique and it was all your own. That board-mounted mechanism idea. But, you know, we got to take steps throughout as I'm trying to develop this course. It isn't going to be perfect. One aspect that's going to be a source of error here is we could call it parallax error, because there is the depth. You could even see that I have printed out a scaled drawing behind this thing, and it doesn't match that scale exactly, right? Because it is perspective. And oh, by the way, okay, wait, I have to stop it. Let's see. Can we stop? Let's stop. Boom. So we're going to have to get rid of some of the points at the end, because I actually, in this video, I actually do hit the stop button onto this thing, so you can see how it stops. So like we like when manipulating the data here, we want to make sure that we don't look at that like a whole long portion of it right here is going to be 0. Because of that. But coming up to the plots, let's take a look. Let's take a look at x on y on top of x right here. And you could see that the lack of repetition, right? There's some variation just because it should be right on top of each other. I mean, I had it on a tripod. It should not have been moving around. Unless the earth is shaking or something, or maybe the table was shaking. I don't know. But it isn't giving you a repeatability. So right there is going to be for sure some amount of error. But we could take a look at the velocity of this. Okay, so there's the velocity. It looks like a better velocity return profile than what we previously had, although we were only going through one section. Let's take a look at the y velocity. Right there. Okay, so that has like that interesting shape. That's a lot more. I think this is the y velocity right here. And that is an interesting shape. Let's take a look at acceleration. Acceleration in the x. Okay. Well, let's take a look at acceleration in the x over here. Acceleration in the x. This is the acceleration in the x. It's kind of has that shape, but a mirror of it, right? And then there's the acceleration in the y. And so there's a bunch of stuff over here, but like in the middle here, it looks like we're getting some pretty good stuff. So there is the position in x. Here is the position in y. And that looks pretty darn good, doesn't it? So this has been a video to show you how to use Tracker. It's not that difficult to use. The real challenge is when the auto tracker doesn't work correctly. But it would be nice to have filters on this to get rid of, smooth out some of the data. But then anytime you do that, it kind of compromises what your data is. But we also want to take a look at magnitudes and try to get some of them mixed up, because once again, this yardstick right here, or the calibration stick, that will adjust some of our our means. One thing we could do, we could have taken this and put it right here and right here, right? And that, according to my problem right here, that's the coupler length, right? And the coupler length was supposed to be 120 millimeters, whereas on here, we don't really know what that is right there. Actually, we could say that we could set this to 120 millimeters. And I don't know if it actually changes what my magnitude is right here. Did it change my magnitude on everything? Let's see. If we went 100, right here, 100. Yeah, it changed everything right there. So 120, boom, will give us, that might give us actually better or more comparable things, because although that distance won't stay the same obviously everywhere, but here at this instant, that's going to be probably as close as we get to 120. So here's a whole bunch of different things to kind of mess with as part of this. And it's also already telling me that I'm near the memory in use. I'm near the maximum. So I want to be careful not to go over 420 or so frames. Maybe that's the limitation of this. So that's my recording. And I don't know. The guitar du jour, it's not a very good guitar, is a black Gibson Melody Maker in the shape of a Gibson SG, right? So this is a Gibson. I bought it off of Tim Britt. He happened to come by my office and he says, "Hey, check this out." And he left the guitar there. And actually, that sounded exactly like it. But this is sort of like your good punk aesthetic. It's out of tune already, and it sounds like Dougie too. I did something wrong with this guitar, man. I gotta send it to a luthier. And there's something about the setup on it just ain't quite right. It doesn't sound like it should. It's got a really good, high quality pickup in it. I swapped the pickup up. I don't know why, but anyway.